So today we're talking about entropy. And entropy is the lack of order or predictability. It is the gradual decline into disorder. With entropy comes spontaneous processes. And a spontaneous process is a process that proceeds on its own without assistance. So there's something you have to know about spontaneous processes, and it is that they are irreversible. For example, ice melting into water is a spontaneous process, and water is not magically going to come back into ice without outside assistance. So the symbol for entropy is S. The symbol for entropy change is delta S. Delta S is equal to final entropy minus initial entropy. A positive delta S
referencing the article
equates to increased disorder. A negative delta S will equate to decreased disorder.
Okay, so those should be in Herdman. If she does not have one,
a spontaneous disorder is more likely when delta S is greater than 0. So when the entropy change is positive, a spontaneous process is more likely to occur.
I'm doing my videos on the chat, so I can. Yes.
Also, during a phase change, delta S is equal to delta H over T. So this when T is constant or given.
This is time consuming. It's pretty easy actually. It's basic addition.
We can do it. This is the only
When discussing entropy, it is important to have previous knowledge of the laws of thermodynamics. The first law of thermodynamics is what you may have already known. Energy is conserved in any process. The second law states that total entropy of the universe increases in any process. So delta S universe is always positive. The third law states that entropy of a pure crystalline substance at absolute zero is 0. The normal boiling point of butane is -1 degree Celsius, and its molar enthalpy of vaporization is 22.44 kilojoules per mole. Now, with using this information, what is the value of delta S when 2.3 moles of butane is vaporized at -1 degree Celsius? The vaporization of butane is an endothermic process, so this value will be positive, stay positive. Okay, all you have to do to find the amount of energy consumed by the gas to boil butane is multiply the amount of butane you have by the molar enthalpy of vaporization of butane. This value comes out to be 51.6 kilojoules. Now, the change of entropy is in joules.
Wait, did I ever actually answer?
Joules
Okay.
over
What is an example of a
Kelvin.
polar molecule that is composed of polar bonds?
So this value in kilojoules, 51.6 kilojoules, has to be converted into joules. And when you move the decimal point 3 places to the right, you end up with 51,600 joules. Now, you also have to convert your degrees Celsius into Kelvin. And you had -1 degree Celsius plus 273 and you'll come out with a total of 272 degrees Kelvin. Now, all you have to do at this point is you have your joules, you have your Kelvin, so divide your 51,600 joules by 272 Kelvin. And that will give you your change in entropy, which comes out to be 190 joules per Kelvin when rounded to 3 sig figs. And this change in entropy is positive. So you can tell that at -1 degree Celsius, butane is more likely to boil because the change in entropy is positive, the spontaneous process is more likely to occur.